Ponra, postdoctoral research scholar from France. I extend my welcome to all our distinguished resource persons. I also like to extend my hearty welcome to the participants of different institutions, students of our college, and other persons who are interested in this seminar. Now I like to say something about our today's topic. Dr. Shah will deliver his valuable lecture on asymmetric hydrogenation of fluorinated olefins. We know nothing about this topic, but we like to enlighten ourselves through the valuable speech of Dr. Sudipta Pondra. Dr. Rajkumar Nandi will deliver his valuable lecture on the prevention and control of COVID-19, a perspective of chemist. This is the most and burning issues in our society today. We all of us are very much anxious about the safety of our life. And then Dr. Abu Tahir, his topic is role of chemistry in human life, is very much useful today. We all know that chemistry practically is our life. Top to bottom, all our essentials are made from the reaction of chemical reaction, we know something, and then of our scientific research today, as I know so far. And then functional liquid crystals, a general concept for formation of donor acceptor materials. Dr. Gautam Biswas will deliver his lecture on nanomaterials. These topics are very interesting as far as I know, and I hope this will help us to be enlightened with this topic in our life, and as a common people, I also think and hope that all will be enriched through this webinar. And finally, I hope the auspicious occasion in the form of international webinar will achieve a grand success. Thank you all and enjoy this webinar. Thank you.
Yes. Thank you, the president of this webinar and the participants of the webinar. It is a special occasion for us that we have got many talents, many scholars from outside our college also. I am a student of literature. I have little knowledge about chemistry, but I know that chemistry has a great role in the development of our society. I participate in this seminar as a silent listener. I think my participation will increase my knowledge about it. I shall listen to their lectures. I thank all of you. I thank the organizer of this seminar and the participants, the speakers who are living in our country and outside our country. Thank you.
Am I audible? Thank you, Manoj. Good afternoon, everyone, and a warm welcome to International Webinar on Recent Advances in Chemistry, organized by Department of Chemistry in collaboration with IQAC Matabhanga College. I welcome everyone on behalf of Teachers Council of Matabhanga College. All we are aware of the pandemic situation going on due to COVID-19 coronavirus, and we are all far away from our working place. Classroom teaching is almost closed. Teaching process continues by online basis. In this situation, this kind of webinar will be really helpful for our students. And I hope that they will certainly have a wonderful learning experience. And not only the students, as our senior teacher, Dr. Gurucharan Das said, that all of us will be enriched with the lecture series of the eminent research persons present here. I won't take too much time now. We are all eagerly waiting for the technical session. On behalf of Teachers Council, I extend my best wishes for this event. Thank you.
Oh, hello. Well, it is my great pleasure to have a part of this international webinar on recent advances in chemistry as the organizing chairperson. At first, I offer my gratitude to our guests, and I express my heartfelt thanks to our speakers.
Thank you, the President of
Department
this
of Chemistry,
webinar
with its
and
3 pillars,
participants
is
of
going to organize the international webinar focusing on the recent advances in chemistry. I congratulate them from my core of heart. Organizing a seminar is not a matter of joke. A lot of hard work is there. Well, as you know, chemistry is a study of composition and structure of matter, and always changes that occur in matter. It is not a merely addition, subtraction, multiplication, division. It is a concept. You have to understand the concept. Chemistry is really all around you. If you have a matchbox and strike it, that is chemical. That someone has designed it and tested it. Chemistry is incredibly interesting. It has everyday connection. You should love and enjoy it. If you can open up your kitchen or freeze and see things, they are made chemical. So you have everyday contact with it. I can say mental chemistry creates interest. Emotional chemistry generates and spiritual chemistry creates loves. However, our environment every increasing chemical pollution associated with and emerging technology. As you know, challenges from the institution and industries is to come together and by reducing or eliminating the use of and generation of hazardous substances. So I hope this international seminar organized by the Department of Chemistry based on the recent I hope this seminar would get great success. And Finally, I thank you. I thank the Department of Chemistry and thank to all of you for hearing me. Thank you.
Thank you, Manojda. Respected President of today's webinar, TIC, special guest, chief guest, distinguished speakers, my fellow colleagues, research scholars, and students. It's always a pleasure to have you here today in the one-day international webinar on recent trends in chemistry, organized by Department of Chemistry, Mathavanga College, in collaboration with IQAC. We are bringing time out of their busy schedule to grace the occasion and encourage our endeavor. In this technical session, we have 5 institutions. So it's time for their speeches to get ourselves enriched. So let me first introduce our first speaker. It is my privilege to introduce Dr. Sudipto Ponra, who completed his B from Vidyasagar University, West Bengal. He pursued his PhD from Kalyan University under the supervision of Professor K.C. Majumdar. He did his postdoctoral research from various universities, including Free State University, University of the Free State, ENSCP Chemie, Paris Tech, and École Normale Supérieure, and Stockholm University. He has over 40 publications in reputed international journals. He is currently working on an industrial process development in collaboration with industrial partner Orgafirm, France. Today, he will deliver a talk on asymmetric hydrogenation of fluorinated olefins. Hope we will be extremely enriched by his talk. So, Dr. Sudipto Ponra, this virtual floor is yours now. So, but we are running, we are out before time, I think. It should be 4:40, now it is 4:25. So what should we do now?
He's in.
He's in, so shall we start? Okay, fine. So Dr. Sudipto Ponra, you please proceed. Shantanda, is he here?
Dr. Ponda? Dr. Sudipto Ponda, can you hear me?
Dr. Sudipto Ponra?
Yes, yes.
Is here. Network issue, I think. So, Shantanda, can you call him?
I think he need to unmute himself. He has muted. His microphone is muted. Dr. Chakraborty, you can request him to unmute. Now it's okay.
Now you can hear me?
Yes, we can hear you.
Okay.
Yes.
Yes, Professor Ponda.
Yeah, I have to share my screen.
Okay.
Just wait a few minutes. I'm trying to share my entire screen, but
okay, no problem.
There is some problem. Cannot see on screen. The option is not coming.
Dr. Ponda, just press the present now. Then you can see your entire screen. Then press it, and you can have a. You can have a screen. Just need to select.
Yeah.
Just select your screen, then share. Yeah, it's working.
Yes, it's sharing, I think. Sharing. Okay, it will take a few minutes.
Just click
Just
there.
minimize your screen.
I think it's
Just
sharing. I
minimize
think.
your screen and yeah. Yeah.
Yes,
Yes.
visible.
So now you can.
Yes. Yes.
Yes.
Okay.
Please. Please.
So good afternoon, everybody. Thank you, the organizing committee, to giving me the opportunity to present my work. First of all, I can say sorry because I have a misunderstanding. I thought everybody will be from the chemistry background, so I choose my research topic to present. So actually, I am interested on fluorinated molecule because it has vast application in pharmaceutical and also agrochemical industry. That's why I choose the topic. But I think still there will be some sufficient people to understand what I did in my previous postdoc in Stockholm University. So my topic is asymmetric hydrogenation, and I choose fluorinated olefin to hydrogenate. Currently, I am working at Semiparitech in collaboration with an industrial company called Exenthis. It's a part of it's a pharmaceutical company, and I am working as a industrial process development of a pharmaceutical drug. Since I'm an organic chemist, I'm synthetic organic chemist. If we look at the recent chemist, especially after 2000, the most recent one in synthetic organic by Heck, Ligosi, and Suzuki. And after that, the second nearest one was in 2005 by Chowan, Graves, and Srock. But my topic is a little bit different of these things. So in 2001, there was a Nobel Prize in asymmetric. I think with the supervisor of my postdoc supervisor, Professor Fred Anderson, and his motivation was chiral catalyzed epoxidation reaction. And half of the Nobel Prize went to Naori and Knowles for their pioneer work in asymmetric hydrogenation. So I think everybody knows what is hydrogenation. So hydrogenation is a chemical reaction. We use hydrogen gas, normal hydrogen gas. So there is two types of hydrogenation reaction. One, you use hydrogen gas. If you do asymmetric hydrogenation, then it's called asymmetric hydrogenation reaction. And in situ, in one reaction mixture, you can generate hydrogen gas and use this hydrogen gas for hydrogenation reaction. This is called ATH, or asymmetric transfer hydrogenation. But my topic is on asymmetric hydrogenation. So I think most of the chemists who did a hydrogenation reaction know the mechanism of the hydrogenation. It's an atomic unequal process. So hydrogen gas, two hydrogen is there. So two hydrogen will add to olefin, and it will give from alkene to alkane. So the hydrogen will activate the metal surface of the catalyst, and you may active metal catalyst, and then hydrogen will transfer from the same side. So one hydrogen will transfer first, and then the other hydrogen will transfer from the same phase. So it's a kind of scene addition. We always have scene addition from the same phase. Wilkinson catalyst. How hydrogenation works? Wilkinson catalyst. Wilkinson catalyst, and then solvent will exchange with one of the ligands, and then hydrogen will attach as a oxidative addition, and then your olefin will attach to the catalyst center, and then there will be migratory insertion of the hydrogen. Is the common mechanism of asymmetric hydrogenation, or you can for Naori's pioneer work for asymmetric hydrogenation. You have a coordinating group. If you have a coordinating group, would enhance selectivity. I think everybody knows what is enhanced selectivity, dash to selectivity. I assume at least organic chemist. And then if you have a coordinating group, then coordinating group will attach to this catalyst and it will control the selectivity, and it will be the same mechanism like oxidative and migratory insertion and reductive elimination to get your hydrogenated product like this. In 2017, 2019, with the in RN, and he is my supervisor, Professor Fer Anderson, and this guy Jingping Yang, he helped me a lot for this type of hydrogenation reaction. So in Stockholm, I work on a iridium NP catalyzed asymmetric hydrogenation. We prepare the catalyst we have based on iridium, and it have a NP ligand. So the mechanism also is almost same like asymmetric hydrogenation. So you have iridium NP catalyst, and it will be activated by hydrogen, and there will be solvent and cord. We have counter anion cord. So it will be exchanged by the solvent. And then it follows the same mechanism as hydrogenation reaction, oxidative addition, then and why I choose I can say, we say organic chemist says fluorine as a phantom atom. So it has electronegativity. So fluorine is the most electronegative atom. So the CF bond is very polarized. So, and another thing is it can increase the bond dipole moment. It has a radius and also have shorter bond length. And the CF and another thing, the size of hydrogen and fluorine is almost similar. So if you replace the hydrogen by a fluorine molecule, the property of the molecule at all. Of property like high thermal and oxidative stability, low polarizability, increased lyophility, and enhanced bioavailability. So fluorinated molecule can be used as a inert bioisotope of hydrogen. So in modern society, you can see approximately 30% of all agrochemicals and 20% of all pharmaceuticals contain fluorine molecule. Society for agrochemicals and pharmaceuticals, and still only 21 biosynthesized molecule contain. You can see the use in pharmaceutical, agrochemicals, medicinal chemistry like liquid medicinal chemistry, material chemistry, in material chemistry especially liquid crystal, dye and plastics, etc. If you look the natural product, so less than 20, I think the actual number is 19 natural products known so far which have chiral fluorine molecule. So we say one thing, that means nature have some difficulties to chirally introduce. Is very, very difficult and it's very challenging. But organic chemists already successfully did that, and I think fluorination method. So you take aldehyde, sophisticated reaction condition. That means agent to get this fluorinated molecule, asymmetric fluorinated molecule. People use SI as a fluorinating agent and N-heterocyclic carbene to get things done with ester. And if you look all the example here in these two reviews, two nice reviews, molecule, they have similarity. So always it have a carbonyl center. So this this is kind of limitation. Go beyond this limitation to this one. First, I will talk about one of my work. What I started before when I hydrogenation of tetrasubstituted olefin. So what is tetrasubstituted olefin? It means in an olefin you have 4 and then you have to hydrogenate it. We have to use our pyridium catalyst to hydrogenate this one. So if we hydrogenate this tetrasubstituted two chiral center, 2 consecutive chiral center, and we have to do it in a asymmetric. Before going to this one, we can say this much type of molecule is very stable, thermodynamically very stable, and sterically very hindered. Because if you have this type of reaction, you have a metal hydride species, and it had coated with the double bond or the all. If a metal hydride species will not get any space to coordinate with the double bond, and then it will be very, very challenging and difficult to hydrogenate this one. With trisubstituted olefin, so if you have a trisubstituted olefin, then 3 different group and 1 you have hydrogen. So if you have hydrogen, the size of hydrogen is very small. So metal hydride species have sufficient space to coordinate with the metal center. So metal hydride species to their olefin. So you can easily hydrogenate to trisubstituted olefin. So hydrogenate. Then we will come to selectivity. So if we hydrogenate tetrasubstituted olefin, we will get 2 consecutive chiral center. But our task is, if we do a asymmetric reaction, we have to get a good selectivity. Means it should be it should give high reactivity and selectivity.